What's going on, guys? In this video we are going to see how to verify whether a given function is a solution to the given differential equation. Now if you look at the differential equation, we have second derivative, first derivative, and this y equal to 0. Now in order to verify this one is true, like whether this given function is a solution, we have to find this first derivative and second derivative and apply in this equation and figure out whether it is giving us 0. Now let's go ahead and find our first derivative. That's going to be dy over dx, and if you take the first derivative of this one, that's going to give us negative e power negative x, and the next one is going to be product rule because we have two different functions, right? So we are going to use product rule. We take the derivative of first one and multiply by the second one, so that's going to give us 2 times e power negative x plus, then we take the derivative of second one and keep the first one, so this is going to be 2x negative e power negative x, and if we simplify this one, that's going to be negative e power negative x, and this is going to be just 2 times e power x negative x plus, so this is going to be negative 2x e power minus x, and here if you notice we have 2 times e power negative x negative, so this is going to be just 1, right? 2 minus 1, that's going to be 1, so this is going to be e power negative x, and here we have negative 2x e power negative x, so this is going to be our first derivative. Now we have to find second derivative too, right? Second derivative is going to be d square y over dx square, and let's take the derivative of this one. Again, this is going to be negative e power negative x, and this is going to be again product rule minus 2 times e power negative x plus 2x times minus e power negative x. Now let's simplify this one, so this is going to be negative e power negative x minus 2 e power negative x, and here we are going to have, this is going to become minus, but this with this minus, that's going to become plus. Here we have minus already, so this minus, that's going to make this one plus, so it's going to be plus 3x e power negative x, and if we combine them together, okay, this is 2x e power negative e power, here it should be 2, right? So this is 2, and okay, so this is 2 and this is minus 3, so this is going to be minus 3 e power negative x plus 2x e power negative x, so this is going to be our second derivative. Now all we have to do is apply these values in this equation and make sure whether we get 0. If we get 0, this means this function is a solution of this differential equation. Now let's go ahead and apply these values in the function. First value we have d square y over dx square. We found out that is this one. So that is negative 3 e power negative x plus plus 2x e power negative x plus 2 times dy over dx. dy over dx we found out right here, that is e power negative x minus 2x e power negative x, and then plus y. So plus y value, we know that e power negative x plus 2x e power negative x, so this is going to be e power negative x plus 2x e power negative x. Now let's simplify this one. We should get 0, but we are not sure. Now let's simplify and make sure it is 0. So here we are going to have minus 3 e power negative x plus 2x e power negative x, 2 times e power negative x, this is going to be plus 2 times e power negative x, 2 times negative 2, that's going to be minus 4x e power negative x plus e power negative x plus 2x e power negative x. Now let's cancel all we can cancel. So this cancels with this. Okay, this and this cancels with this one because 2 to 4 and this negative 4, right? And here we have plus 3, 2 plus 1, 3, negative 3. So this is definitely equal to 0. So we are getting 0 equal to 0. So this function is a solution for this differential equation. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.